maximum number that you can do, and that generally will be fine in general use. Now the next two items are integration step, which is something that actually I'll come to later. It's quite an important topic in itself, but for now we'll skip on to the next section. As I said, I cover that in detail in a little while. So let's just close down system management and have a look at script. Now the final rollout offers the ability to implement two scripts that can be acted upon in different ways, basically at different execution frequencies. The first one is called every step update, and this script is executed once for every integration step in your system. As I said, the previous rollout had the integration step. Now it's intended for use on scripts that are heavily history dependent, i.e. when the script depends on the position of the particles arrived at with complex interactions of speeds and forces over time. Now history dependencies is something that may not make that much sense, but I'll give you an example. You have a particle flying through the air, and as it flies through the air it gets affected by gravity, and that particle will follow a certain arc through the air based on how strong the gravity is and how fast it's traveling. Now if you went back and changed the strength of the gravity or the speed of the particle at the beginning of the simulation and played it through again, you'd get a different curve, and that's called history dependency. Basically, if you went to frame 65, the position of that particle on frame 65 is not going to be the same as it would have been if you hadn't changed those parameters, and that's because it's dependent on its history. You've changed its history by changing the parameters, and that ripples through the entire particle flow. So this is history dependency, and when you have a script that needs to be run on particles that have that dependency criteria, then you should use every step update. Now the second script is called final step update, and this is not quite as rigorous as the first option. It only gets run once per frame, and it's not history dependent. So if you ran all the way to frame 55 in a script and then ran, it would then run this script. It only gets executed on that frame. Every step update will get executed on every integration step leading up to that frame. So the two are very different in the way that they're executed, and for that reason they can be used for controlling different situations. Okay, so that's it for the rollouts. Okay, so let's have a look at the source event in particle view. Now, as I said, this is particle view's corresponding entity compared to the source icon in the viewport, and as I said, the same rollouts are pretty much visible in it as well. You can see you've got the script rollout here, system management here, and emission here. It should be noted though that if you look in the viewport, that the selection rollout is missing. That's because you can't really use it within particle view. You can only make selections in the viewport, so that particular rollout is omitted because it just doesn't make any sense in particle view. I also showed you just now that each source icon in the viewport has a corresponding source in the particle view, and generally that the sources will be called something along the lines of it's a formula which is the default formula, which is PF particle flow source and a number. This is the first one that was created, so it's PF source 01. If you had two, you'd have that one would be called PF source 02, and so forth. Now what's special about this particular event, although it's called PF source 01, it is an event. Don't make any mistake about that. You can take operators from here and you can drop them into it in exactly the same way you can drop them into the other event. So what is global about this event is that any operator that is placed within it will apply to all of the events that flow from it. This means that, for instance, that a speed operator placed into the global event will override all of the speed operators in the events that follow. In general, the main operators that would make sense in here are the render operator, and you can see that's actually here. The material operators that would allow you to apply materials to every event in your entire flow, and the cache operator. Now the cache operator, which is something which we'll come to a little bit later, and it's also covered very heavily in DVD3 in the series. The cache operator is used to store the data of all your particles, or rather it can be used to store the data of all of your particles on a frame-to-frame basis. And this means that when you play back the particles in the viewport, they're no longer history dependent. You know, if you scrub to frame 60, particle flow will calculate the particles up to frame 60, and they will be cached when the cache operator is in use. And that means then you can scrub all the way back and forth between frame 0 and frame 60, and it won't have to calculate the particles anymore. It's got them cached in memory. So the cache operator can actually be used on an event by event level, if you wish to use it that way, or, you know, which is generally more useful, you can put it into the global event, and it will affect all of the events that flow from it. It becomes a global cache rather than just a local cache to the events. The only real guideline I can give you on working with operators and putting them into the global event is, you know, if they make sense in a global manner, then they possibly will work in the global event. Really, the only thing you can do is to try things out and see how they work. Due to the nature of particle flow, it's an extremely flexible system, and it's impossible really to describe how every operator would work under every circumstance with every other operator. It's just not possible to do that. I can only really describe general behaviors and what the operators are intended to do, and as you can imagine, using an operator on an individual event is quite different to the way it actually might work on a global sense. So you just have to experiment really and find out, you know, just exactly how each operator works. But as I said, there are certainly you know, the render operator, the cache operator, material operators, shape operators, they all work perfectly fine used in a global sense. So, you know, start there and try out other operators, and you can see whether they work well or, you know, whether there are individual issues. So anyway, before we go any further, let's have a look at the user interface elements for particle flow.